Celebrate Thanksgiving with Safeway. This week at Safeway, get whole Signature Farms frozen turkey, 10 to 15.5 pounds for $8 each, or 16.1 to 22 pounds for $10 each. Member price with a minimum $50 purchase, limit one per household. Plus, packs of Coca-Cola, Pepsi, 7-Up, Dr. Pepper, or AHA Sparkling Water are buy two, get three free. Limit 3 free items. Also this week, get 5-pound bags of Signature Farms russet potatoes for 97 cents each with digital coupon. Limit 1. Visit Safeway.com or head in store for more details.
This is SpaceTime, Series 25, Episode 50, for broadcast on the 27th of April, 2022. Coming up on SpaceTime, a new study warns that plate tectonics appears to be slowing down on planet Earth, discovery of the hottest rocks on Earth, and confirmation that the Milky Way's disk isn't flat but curved and warped. All that and more coming up on SpaceTime.
Welcome to Space Time with Stuart Gary.
A new study claims that seafloor spreading of the Earth's tectonic plates along the planet's mid-ocean ridges has been slowing down. The findings, reported in the journal Geophysical Research Letters, are based on a global analysis of the last 19 million years of seafloor spreading rates. New oceanic crust forms continuously along rifts thousands of kilometers long on the seafloor, driven by plate tectonics. As subduction pulls all crust down, rifts open up like fissures in an effusive volcano, drawing a hot crust towards the surface. Once on the surface, the crust begins to cool as it gets pulled away from the rift, replaced by a hotter, younger crust. This conveyor belt-like cycle is called seafloor spreading, and its rate shapes many global processes, including the sea level and the carbon cycle. Faster rates tends to cause more volcanic activity, which releases more greenhouse gases. So, deciphering spreading rates helps to contextualize long-term changes in the atmosphere. Today, spreading rates top out at around 140 millimeters per year, but they peaked around 200 millimeters per year in some places just 15 million years ago. This slowdown is a global average, the result of varying spreading rates from ridge to ridge. For the study, scientists examined 18 different ridges, but they took an especially close look at the Eastern Pacific, which is home to some of the globe's fastest spreading ridges. Because these slowed greatly, some by nearly 100 millimeters per year slower compared to 19 million years ago, they dragged down the world's average spreading rates. It's a complex problem to solve, made more difficult by the seafloor's slow and steady self-destruction. The study's lead author, Colin Dalton from Brown University, says scientists really know more about the surfaces of other planets than what they do about Earth's own seafloor. One of the challenges is this lack of perfect preservation. You see, the seafloor is constantly being destroyed, so scientists are left with an incomplete record. The seafloor is being destroyed in the subduction zones, where the ocean crust slides under the continents and sinks back down into the mantle. It's then reforged at seafloor spreading ridges. The cycle of creation and destruction takes about 180 million years. That's the age of the oldest known seafloor. The crust's magnetic record tracks this pattern, producing identifiable strips every time the Earth's magnetic field reverses. Dalton and colleagues studied magnetic records from 18 of the world's largest spreading ridges, using seafloor ages and their areas to calculate how much ocean crust each ridge has produced over the past 19 million years. Of course, each ridge has evolved a little differently. Some lengthened, some shrank, and some sped up, but almost all of them slowed down. The overall result of Dalton's work is that average seafloor spreading across the planet slowed down by as much as 40% over that time. The authors think the driver might be located at subduction zones rather than from spreading ridges. For example, as the Andes mountain range grows along the western edge of the South American continent, the mountains push down on the crust. Dalton says think of it as increased friction between two colliding tectonic plates. A slowdown in convergence there could ultimately cause a slowdown in spreading at nearby ridges. And she says a similar process could be happening underneath the Himalayas, with a rapidly growing range slowing the spreading along ridges in the Indian Ocean. However, Dalton points out that added friction can't be the only driver of the slowdown. That's because she's found slowing rates globally, but the mountain growth is only regional. So, large-scale processes like changes in mantle convection could also be playing a role. In all likelihood, she thinks it's probably a combination of both. To learn more, Dalton hopes to eventually collect absolute plate speeds rather than just the relative speeds used in this study, and these will better allow her to determine the true cause of the slowdown. This is SpaceTime. Still to come, discovery of the hottest rock on Earth, and confirmation that our Milky Way's disk isn't flat but curved and warped. All that and more still to come on SpaceTime. Okay, time for a break from our show and a word from our sponsor, NordVPN. So, the message is very straightforward. NordVPN is the perfect solution to keep your data safe and secure while you're online. Did you know they have a kill switch technology which makes sure that your information will never be exposed, not even for a brief nanosecond? And NordVPN is rated by many as the fastest virtual private network service available. And that's one of the many features they have which I've experienced for myself. But don't take my word for it. Check out the myriad of endorsements on their website, ranging from big-name tech celebrities right through to everyday folk. It's simple. Keep your personal data private and secure with NordVPN. You'll have peace of mind knowing that your information and your family are safe and sound without having to worry about any potential threats. And we at SpaceTime can help you get started because we've got a special URL with a special deal for you as a SpaceTime listener. You can grab your exclusive NordVPN deal by going to nordvpn.com/Stuart Gary and use the code Stuart Gary to get a huge discount off your NordVPN plan. Plus, we'll give you one additional month for free and a bonus gift. And of course, it's all completely risk-free with Nord's 30-day money-back guarantee. So give them a try and see what you think for yourself. Check out just how easy it is to keep your data protected. That URL again is nordvpn.com/Stuart Gary and use the code Stuart Gary at the checkout to get a huge discount off your NordVPN plan, plus one additional month for free and a bonus gift. And as we mentioned earlier, it's completely risk-free with Nord's 30-day money-back guarantee. So you've got nothing to lose and there's so much to gain. So grab our NordVPN deal today. And of course, we'll include the URL details in the show notes, and you can find them on our SpaceTime website. And now, it's back to our show.
You're listening to SpaceTime. SpaceTime with Stuart Gary.
Geologists in Canada have confirmed the discovery of what was once the hottest rock on Earth. The black glass-like cubic zirconia was forged at a temperature of 2,370 degrees Celsius when an asteroid slammed into the Earth 36 million years ago, creating what is now the 28-kilometre wide Mestaston Lake crater in Labrador. The rock was first uncovered by Michael Zanetti and colleagues on a Canadian Space Agency-funded study in 2011. Zanetti found the rock contained small zircon grains. Zircons are extremely durable minerals that crystallize under extremely high temperatures and pressures. By analyzing the structure of one of the zircons, Zanetti was able to determine how hot it was when it was formed. But to confirm the initial findings, scientists needed to date far more than just one zircon. So in the new study, scientists led by Gavin Tolometti from Western University found and analysed 4 additional zircons in samples collected between 2009 and 2011, confirming the original 2011 discovery. Importantly, the new samples came from different types of rock at different locations around the impact site. This also gave a more comprehensive view of exactly how the impact event heated the ground. 2 of the zircons came from rocks that melted and resolidified. A third came from a glassy rock that formed in the impact itself. and the fourth came from sedimentary rock that held fragments of the glass formed in the impact. The findings, reported in the journal Earth and Planetary Science Letters, also showed that the samples included reedites, a mineral formed when zircons undergo high pressure and temperatures. The authors found 3 reedites preserved in the zircon grains, together with evidence suggesting 2 more had formed but then crystallized when temperatures exceeded 1200 degrees Celsius, at which point the redite was no longer stable. The authors believe the redite was formed at pressures of around 30, potentially even over 40 gigapascals. And this indicates the sorts of pressures the minerals around the impact site must have experienced during the crater's formation. Of course, the impact site itself experienced temperatures and pressures so high it simply melted and vaporized the rock. This is space-time. Still to come, confirmation that the Milky Way's disk isn't flat, but rather curved and warped. And later in the science report, a new survey claims people who live within 10 kilometres of a wind farm report more noise issues from other sources, such as insomnia, stress, and snoring spouses. All that and more still to come on SpaceTime. Astronomers have used thousands of variable stars to develop a new three-dimensional map of a quadrant of the Milky Way, which confirms that the galaxy's disk isn't flat, but rather warped and curved in the shape of an S. The stars, known as classical Cepheid variables, are often used to determine stellar distances. Classical Cepheid variable stars are massive hot young stars, which burn hundreds if not thousands of times brighter than the Sun, and are visible through vast clouds of interstellar gas and dust that often obscure dimmer stellar bodies. What makes them special is they change in brightness or pulsate at regular intervals based on their mass. So by measuring their pulsations, astronomers know how massive they are. And by knowing their true mass, astronomers know how luminous they are. They can then look at how bright they appear to be compared to their true brightness to calculate how far away they are using the inverse square law. It's the same as looking down a road at a row of street lights and seeing the more distant lights appearing to be fainter than those nearer. Undertaking very precise measurements of thousands of these stars has allowed scientists to develop three-dimensional maps, filling in details of the galactic disk not previously known. One of the study's authors, Prismic Roz from the University of Warsaw, says by measuring the distance from the Sun to thousands of these individual Cepheid variables scattered across the Milky Way, the observations are helping to chart the Milky Way galaxy on a more detailed scale than ever before. The new maps are providing a broad view of the Earth's place among the stars and reveal that the structure of the Milky Way stellar disk isn't flat, but rather warped and twisted. Much of astronomy's current understanding of the spiral shape and structure of our galaxy is based on indirect measurements to celestial landmarks and inferences based on other galaxies in the universe. However, co-author Jan Skoron, also from the University of Warsaw, says the galactic map drafted by those limited observations remains incomplete. So the authors charted the distance to more than 2,400 Cepheids throughout the Milky Way, most of which were identified by OGLE, the optical gravitational lensing experiment, a project which more than doubled the number of known galactic classical Cepheids. By determining the three-dimensional coordinates of each distant pulsating star relative to the Sun, the authors were able to build a large new three-dimensional map of the Milky Way galaxy. Study co-author Dorota Skoron, also from the University of Warsaw, says the new map illustrates and helps constrain the previously observed shape of the galaxy's warped and twisted stellar disk.
Since many centuries, astronomers have been aware that the Earth, the Sun, and other planets in the solar system, together with billions of stars seen with telescopes, form our galaxy. These stars, if observed far from the city lights, look like milk spilled across the sky and form the band of the Milky Way. However, the internal structure and history of the Milky Way are still far from being well understood. in part because it is extremely difficult to measure distances to stars in the outer regions of our galaxy. Fortunately, there is a type of variable stars called classical Cepheids, which are bright enough to be seen out to the edge of our galaxy. And in the issue of Science, we have presented a unique three-dimensional map of the Milky Way that is based on precise distances to thousands of these stars. Cepheids are young, pulsating supergiant stars. Their brightness changes in a very regular pattern with a well-defined period, which may range from hours to several dozen days. We used our telescope, located at Las Campanas Observatory in Chile, to image the entire visible Milky Way over 100 times. We then searched for stars that change their brightness in a specific pattern. Cepheids are ideal to study the Milky Way structure because they follow a relation between their pulsation period and their luminosity, meaning that we can measure their intrinsic brightness based on their period. The distance can then be determined by comparing the apparent and intrinsic brightness of the star. Distances to Cepheids can be measured with an accuracy better than 5%.
Our three-dimensional map of the Milky Way is the first map that is based on direct distances to thousands of individual objects, as distant as the expected boundary of the galactic disk. Our map shows that the Milky Way disk is not flat. It is warped and twisted far away from the galactic center. Warping of the disk has been detected before, but this is the first time we can use individual objects to trace its shape in 3 dimensions. Warping may have been caused by the past interactions with satellite galaxies, interactions with intergalactic gas or dark matter.
We can also estimate an age of a Cepheid based on its pulsation period. The youngest Cepheids are located near the galactic center, while the eldest near the Milky Way's edge. We found many elongated structures in the galactic disk that are composed of stars of similar age. We propose that stars located in those substructures have formed around the same time in one of the spiral arms. However, Cepheids that were formed in a spiral arm do not currently follow the exact location of that arm because rotation velocities of spiral arms and stars are slightly different. A simple simulation that we have performed to test such a hypothesis. We have injected several star formation episodes into the spiral arms and assigned typical motions and rotation velocities to the stars within them. We then look at what the galaxy looks like after millions of years and find that the simulated and observed structures are strikingly similar. This shows that our idea about the recent history of the galactic disk is plausible and can explain the structures we see.
And in that report, we heard from University of Warsaw astronomers Dorota Skorin, Presmek Roz, and Jan Skoron. This is SpaceTime.
Celebrate Thanksgiving with Safeway. This week at Safeway, get whole Signature Farms frozen turkey, 10 to 15.5 pounds for $8 each, or 16.1 to 22 pounds for $10 each. Member price of the minimum $50 purchase, limit 1 per household. Plus packs of Coca-Cola, Pepsi, 7-Up, Dr. Pepper, or AHA sparkling water are buy 2, get 3 free. Limit 3 free items. Also this week, get 5-pound bags of Signature Farms russet potatoes for 97 cents each with digital coupon. Limit 1. Visit Safeway.com or head in store for more details.
And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that people at risk of developing heart problems could also be at risk of developing more severe COVID-19. And the findings, which were presented to the European Congress of Clinical Microbiology and Infectious Diseases, suggest the dangers hold true even if the patient hasn't developed any heart problems yet. The authors evaluated the heart health risk of some 100,000 people using an English hospital data set. They then looked at the outcomes of 4,000 people who tested positive for COVID-19. While the rates of COVID-19 infection were similar for those with both higher and lower cardiovascular risk, researchers say the death rate was 310.7 per 1,000 patients in the heart risk group compared to just 23.9 per 1,000 patients in the low risk group. They found that hospitalization and ICU rates were also substantially higher. Over 6.2 million people have now been killed by the COVID-19 coronavirus since it first escaped from Wuhan, China. And the World Health Organization warns the true death toll is likely to be at least double that amount, with over 500 million confirmed cases globally. Meanwhile, a study reported in the Lancet Medical Journal claims the most accurate modelling so far suggests the true death toll is likely to be around 18.2 million people since the virus first appeared in the area surrounding the Wuhan Institute of Virology back in September 2019. A new survey by people who live within 10 kilometres of a wind farm report more sleeping issues from other sources such as insomnia, stress and snoring spouses than from the noise of the nearby wind farms. The study by Flinders University surveyed some 500 South Australians, finding the proportion of residents living near wind farms who reported moderate to severe sleeping difficulties for any reason was little different to those living in quiet rural areas. In fact, the authors found that people living next to a main road where there was lots of traffic noise were almost twice as likely to report noise-related sleeping disturbance compared to those living near wind farms. A new study claims a previously presumed extinct species of orchid called Paracephalum organi, more commonly known as the mignonette leek orchid, has in fact been hiding in plain sight. The orchid was first collected from a single population in the Victorian subalps back in 1929, but has not been collected since 1933 despite extensive surveys by orchid enthusiasts. And so it was considered extinct under the Flora and Fauna Guarantees Act and by the Threatened Species Scientific Committee. Then, in the year 2000, scientists described a very similar-looking orchid which they had found in the Kosciuszko National Park in the New South Wales Snowy Mountains and had been named Paracephalum retroflexium or Kiandra leek orchid. Now, a new study by the Victorian Royal Botanical Gardens and reported in the journal Phytotaxia has shown that the two orchids are in fact one and the same species. SkyMaster, the satellite component of the NBN, Australia's national broadband internet network, uses two geostationary telecommunications satellites built by Space Systems Lorel and launched in 2015 and 2016 to provide connectivity in remote rural, offshore and outback areas where the NBN's fibre optic cables don't reach. Each SkyMaster spacecraft has 101 Ka-band spot beams offering 80 gigabytes per second of bandwidth to provide high-speed broadband services to some 400,000 Australian homes and businesses in these rural and remote areas. However, the service is now being forced to compete against newly emerging satellite broadband giants like Starlink and OneWeb. With the details, we're joined by technology editor Alex Zaharov-Reutt from ITWire.com.
So SkyMaster has a 25 megabits download and 5 megabits upload speed plans. But the problem with the original SkyMaster plans is that you had monthly limits. So you had 65 gigabytes of anytime data and 235 gigabytes of data for use in off-peak hours. And, if somebody used that, if kids were uploading or updating their phones or consoles or, something was left on, you could be using all of your data for that month in just a day or a week and still have weeks left and no longer have any connection at all. And, of course, those particular plans, $55 a month, and there's cheaper plans as well, but you get lower amounts of data. So this new SkyMaster Pro plans now give you a daily limit. So they give you 5 gigabytes during peak hours and 5 gigabytes off peak for 10 gigabytes per day. And that's at the 25 to 5 speeds. And so that is on this NBN SkyMaster Pro via a company called Activate Me.
How does that compare to Starlink and OneWeb and ones like that?
Well, Starlink is giving you unlimited data at speeds of from 50 to 150 megabits or speeds of between 100 and 200 megabits with unlimited data. So you don't have to worry how much you're using, and you're getting speeds that are 4 to 8 times faster. And there's a business service that will go up to 500 megabits, but you've got to pay a lot more. So $139 a month is a pretty good deal. The only problem is that Starlink isn't available everywhere as yet, and a lot more people would be in the SkyMaster footprint. So this change to give daily allowances stops the ability for a household to use their entire 300 gigabyte allocation in the space of a few days and fill it up with days or weeks left in the month where they've got no internet at all and then they have to pay for a second satellite dish, and that would have difficulties itself. But there is, via the Activate Me people, a $59.95 plan which gives you 3 gig in peak and 3 gig in off peak. So there is a cheaper plan that's almost half price. It's $10 more than half price. But this gives users in rural and regional areas that require a satellite connection a much better deal. And clearly it's a way of competing against Starlink, who's offering much better download speeds and a much more generous download limit, effectively unlimited. It does actually cost more, $40 more on the most expensive plan, but it's not available everywhere as yet. And no doubt when Starlink is more widely available, then SkyMaster will be forced to compete even harder. But at the moment, they're trying to preserve resources and preserve the amount of capacity on the network. And clearly, they don't have as much capacity as Elon Musk does. But it's a step in the right direction. One day it'll just be unlimited completely on satellite via NBN as well. But at the moment, this is a pretty good update.
That's Alex Zaharov-Reutt from ITWire.com. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgarry.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGarry on Twitter, @SpaceTimeWithStuartGarry on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.